Hello, my name is Ruth Sabariego. I'm the Program Director of the Master in Energy Science, Energy, and I'm going to guide you through the following presentation. First of all, why would you become an energy engineering? The first thing that comes to my mind is that energy is one of the global goals proposed by the United Nations for Sustainable Development. It's indeed global goal number 7. The goal is to provide energy where and when requested, at that precise place and time where energy is needed. That comes together with the challenges of the climate change, so the energy should be clean so that climate is not affected. We are able to stick to the objectives by the governments. The energy supply should be guaranteed at any moment, and the cost of this energy should be affordable for any person who needs to access this energy. Our energy system is in transition. We are going from fossil fuel plants to renewable energy production, mainly photovoltaic and wind, but we may also think about a future construction or a fusion reactor, which is in our dreams, but maybe a possibility in the future. In the past, if we think about heating, we had boiler systems. Now we are going to heat pumps. If we think about mobility, our gasoline cars are being replaced by electric cars or hybrid cars. The trains that in the past were steam power are now fully electric, and the airplanes are now being thought as fully electric. We are not yet there, and prototypes like the one on the slide, fully powered by PV, are not yet available for commercial use. But that's where we are going. With regard to the nets, they must accommodate a lot of heterogeneous systems that comprise not only electricity, heat, but also fuels and data. We have now the houses connected to the grid that are powered by their own PV. There are wind turbines connected to the grid with all the difficulties that brings with them. And we have more and more smart devices that provide data that help optimizing the good functioning of our networks. The network is then something very complicated that integrates the generation and transmission from classical plants like coal, nuclear, or hydraulic plants, but also the renewables like solar and wind farms. And that to guarantee the supply to customers at the residential level, and the industrial level, and at the commercial level. Together with this, we have more and more smart meters that provide some additional information for better optimizing the complex grid. So the coupling between all these elements in this system is complicated and has to be optimized in an efficient way. Besides that, we have to handle the markets, so the offer and demand of energy has to be regulated in order to guarantee an affordable price for everybody at any moment. And that taking into account also the European policy concerning energy and taking into account environment and the climate change. Decisions like are we going to close nuclear centrals are taken at the political level, and we have to cope with it in the technological level. Also, legislation has to be adapted, and we have to follow those changes for better work in the frame of the energy. Our program objectives are then to apply science to develop, design, and produce energy-related products and services that are useful to the society and that within the social, economic, and environmental and energetic constraints. The program is highly multidisciplinary, integrating knowledge and methods from different disciplines and professions. The new developed technologies are to be used alone or to be integrated and coexist with existing ones. Creativity and innovation are key to our students and will help them to find a job in the technology sector. The opportunities after graduation are numerous. Young graduate engineers get mostly technical positions for design, develop, operate, optimize production and energy system, for system integration, for logistics and techno-commercial functions, consultancy, and if we look further in a possible career, they get sometimes to policy positions in industry or government, and some become leaders in engineering offices and research centers. Where are our graduates? On the slide you can see some of the companies that have part of our graduates. The variety is big, and you can see firms that focus on research, but there is energy companies, but not only, and also some research centers and institutions. Concerning the students that enter our master, we have 4 different types of inflow. First inflow is the bachelor's with combinations major electrotechnics and minor mechanical, or the other way around, major mechanical, minor electrotechnics. Those have the perfect combination of background, and they are admitted immediately without any adjustment course. The second inflow corresponds to other bachelor combinations that must follow some adjustment courses, a maximum of 6 credits that can be in fact replaced by some elective courses in the master itself. So that means that there is no additional weighing with regard to the academic load that these students are going to get. This inflow comprises students with a major chemical technology, mechanics, electrotechnics, and a minor on mechanics, business management, or living systems. Third type of inflow are other possible bachelor combinations that you can think of. And there we have an adjustment program of up to 24 credits. 6 of these 24 credits can be taken in the master, and the rest require an additional enrollment in a preparatory program. In that case, it's possible to move part of the courses of phase 1 to phase 2 to accommodate these preparatory courses. Those preparatory courses are mainly courses coming from the bachelor on mechanical or electrotechnical engineering. The fourth inflow are students coming from other masters and bachelors, and those students don't have any background on mechanical engineering or an electrical engineer, so they are going to need a preparation program. up to 60 credits and maximum 72 credits. This preparation program that can be found in the web link that you see on the slide comprise some courses on generic science and mathematics, and then some courses particular to the bachelor on mechanics and the bachelor on electrical engineer, plus a project course where they can choose from the mechanical or for the electrical engineering bachelor. Possible some additional courses may be needed, like electrical networks or basic electronica. It is also possible to follow a summer school for starting the Master Energy. There is no obligation of doing that. It consists of half a day about Master Energy and then the preparation program. For this preparation program, it is also possible to take the exams during the August-September exam period. And in case of passing successfully these exams, it's possible to apply for an exception of the courses in the preparation program. The inscription is to be done before June 13th. More information on this summer school can be found also on the link indicated on the slide. Concerning the structure of our master, the phase 1 comprises 60 credits that are compulsory, a core program of 54 credits, where we have a good balance between the different topics touching electrical energy, thermomechanical energy, and techno-economical aspects of energy. Besides those 54 credits, we have to add 2 projects, 1 per semester. There is no conflict in the programming of these courses, so there is no overlapping as everything is compulsory. Concerning phase 2, we have there more elective courses, and it's related to the specialization. The students will have to choose between 3 different options: electrical energy, thermomechanical energy, and general techno-economical energy knowledge. For these 3 options, the chosen option, you will have to take at least 12 credits and 3 credits from the 2 other options, and then there are 6 more credits that you have to choose freely between the 4 list of courses that are provided. So these 3 corresponding to the options plus the list corresponding to complementary technical knowledge. To that, we have to add 6 more credits of the broadening program and 6 credits of the general interest courses. The master is completed with the master thesis, which is a long research work that ends with a manuscript, also quite long, and that you have to choose at the middle of the first year of the master. Besides the training that we provide inside KU Leuven, you may choose to have training also abroad or at home, but outside the university. I'm referring here to the industrial experience or industrial traineeship that you can choose to follow, and that would consist of 4 to 6 weeks in a company where you will have an intensive training that you will have to report and present at the end of this internship to get the credits. Besides that, you may also opt for following some add-ons intensive courses, what we call the add-ons week, and that's possible once during the Master Energy. There is also a possibility for applying for an Erasmus exchange, and that can be done per semester or per year within the master. Finally, besides the two classical options of the master, Master Energy and Master Energie in English and in Dutch, you may opt for the EIT KIC Master. That is a variant of our master organized by the European Institute of Technology, focused on education, research and innovation and entrepreneurship. That aspect of entrepreneurship is maybe the main difference with regard to our central master. At KU Leuven, you have two options: energy for smart cities and smart electrical networks and systems. Both of them have in common that they have 1 year at KU Leuven with us and 1 year abroad at KTH, so in Sweden. If you are interested in this kind of exchange, you may contact Professor Johan Rissen or Mar Martinez for getting more information as soon as possible. For finishing this presentation, I would like to point out the assistance of our research center Energyville that brings together KU Leuven, Vito, IMEC and U Hasselt on research around energy with markets, with storage, networks and PV mainly, and that provides a new opportunity for doing your master thesis in a real research environment with connections to international researchers straight away and around the corner. So that's everything I wanted to say. I hope I've been able to convince that energy is important and that we need you. See you in the chat. Thanks.